This video is just a continuation of the properties of logarithms lesson. This will be applying the properties of logs, which if you remember, the main properties are if you are adding two logarithms that have the same base, you could combine them into one with that base and multiply. Or if you are subtracting two logs with the same base, you could combine them and divide. And if you're taking the logarithm to a power, that power could be moved in front. So these first exercises are just applying those properties to be able to simplify some of these logs without actually using the log function in your calculator. So the first example says use log base 4 of 3, which is about 0.7925, because 4 to the 0.79 power is about 3. And log base 4 of 5 is 1.1610 to approximate the value of each of these expressions. Okay, so now there are also some logs from our properties that we should know mentally. So those that we could include would be that the log base 4 of 4 would be 1. We would know the log base 4 of 16 is 2. We would also know that the log base 4 of 2 would be 1/2, because the square root of 4 is 2, and that would be, and the square root is the same as the 1/2 power. So you have to always keep in mind some of them that you can do mentally. All right, so number 1 here, we want to break this up into the logs, either log base 4 of 3 or log base 4 of 5, or any of those that we can know mentally. So getting started here, we could break this up into log base 4 of 2 plus the log base 4 of 9. Because 2 times 9 is 18. Now I do know the log base 4 of 2 is 1/2. Log base 4 of 9, I could then write this as log base 4 of 3 squared, and then that 2 can be moved out in front. So then I would have the log base 4 of 2, which is 1/2, or 0.5, plus 2 times the log base 4 of 3, which is 0.7925. All right, then at that point I could use my calculator and just take 0.5 plus 2 times 0.7925, and you would get a total of 2.085. Okay, now 4 to the second power is 16, so a little 4 to a little bit more than 2 would be about 18, so that seems reasonable. Number 2, log base 4 of 15. This one's a little more straightforward. I could write this as log base 4 of 3 plus the log base 4 of 5. And I know both of these. I know the log base 4 of 3 is 0.7925. And log base 4 of 5 was given to be 1.1610. And then I would simply add those together. So I'd have 0.7925 plus 1.1610, which would be 1.9535. Number 3, we're dividing two logs, so here we're just going to subtract them. So log base 4 of 5 minus the log base 4 of 3. So I'm going to take my 1.1610 and I'm going to subtract log base 4 of 3, which is 0.7925. Which should be about 0.3685. The fourth one here we're dividing, so I'm going to subtract log base 4 of 3 minus the log base 4 of 4. Log base 4 of 3 is 0.7925. Log base 4 of 4 is 1. So again, I could take 0.7925 and subtract 1. And this ends up being a negative 0.2075. So that's using properties of logarithms to simplify logs. Basically a practice of using those properties. Now we're going to solve some logarithmic equations. So remember, the logarithmic equations, the methods we've used so far is if we get them into a single log, then we would simply change the form and solve. If we have multiple logs, we would like to get a log equal to another log. And if they have the same base, then we could set, in this case, x equal to y. All right, so number 1, I'm subtracting 2 logs here on the left side. So I could write this as log base 4 of 48 over n equals a log base 4 of 6. Now again, same base logarithm, so 48 over n should equal 6. I'll set these equal. Bear with my stylus here. And then I could multiply both sides by n, which would give me 48 equals 6n. Divide, and n would equal 8. What are you doing, Lisa?
Good Morning America said you should sit in a place like that with a view and stuff.
Oh,
Yeah, and dress up like you're really at school. Just wear jeans and a nice shirt.
sure.
They were on this morning. The lady had a whole little corner of her house set up like an office.
Oh,
And she was doing a presentation to all of the people watching. It
yeah.
was really kind of neat to watch.
See, on mine, I don't usually, I just upload like a document into this,
Yeah.
so they don't really see me or my face, they just see the work being done.
Oh, okay. Like
So.
Mr. Khan.
Yep, Khan Academy,
I
yep.
love him. Just love him.
Yep,
I have problems, I see, Mr. Khan.
there you go.
All right, you can tell him I'm sorry for interrupting your group.
No problem.
Bye. Have a good one.
You bet, take care.
Thank you.
So now I have a single form, or single log, so changing the form, I have 10 squared is equal to a squared minus 6a. So then I'd have 100 equals a squared minus 6a, which is a quadratic. So I'm going to get this to equal 0. I got a little space issue here, so I'm going to move up to the top. Hopefully this is okay. I'm going to get that to equal 0, so I'm going to subtract 100. So I'd have a squared minus 6a minus 100, which is a quadratic. I'm going to factor this, or try to, so I have a and a. And now I need factors of 100 that would differ by 6. So 10 and 10, I could use 8, does not go into 100, 4 goes in there 25 times. And this particular quadratic will not factor. So I'm going to use the quadratic formula, which is going to be negative b. So that'd be positive 6 plus or minus the square root of. My discriminant would be b squared, so I'm grabbing my calculator right now. 36 minus 4 times 1 times a negative 100, which gives me 436 divided by 2a, which would be 2. Now again, using my calculator, I'm going to go parentheses 6 plus the square root of 436. I'm going to close those parentheses and divide by 2. That gives me a solution of 13.4 approximately. And then if I do the subtraction, so I'm going to go 6 minus the square root of 436. That gives me a negative 7.44, or 7.4. Now, plugging these back in, if you put negative 7.4 right in here for A, you cannot take the log of a negative number, so that would be an extraneous solution. So 13.4 would be your only solution. Okay, so that's an excellent question. They're using properties of logs, and then a little review in quadratics.